All right, so we're still on matrix. What we're looking at now is multiplication of matrix. So with multiplication of matrix, I think this sometimes give students a bit of problems, but as I said before in the previous, well, same video, because I'm going to combine them. It's simple. You just have to understand the concepts, and they probably sometimes teachers don't really get to the point. So yeah, let's just get into it. Now when you're multiplying matrix, the matrix, they don't have to be of the same order. They don't. So the condition for multiplying matrix, you have to pay attention to the order of the matrix. For example, let's say we had a matrix A. Now matrix A is let's say 1, 2, 3, 4. So from looking at A, you know that the order of A is a 2 by 2 matrix. Now let's say we had another matrix, and this matrix is called B. Now B is let's say 1 and 3, which is a vector. You can also call matrix B a vector. So matrix B, the order for matrix B, remember you pay attention to the row by its column. So we have 2 rows and 1 column. Now we have to make sure that the matrix, they are conformable, meaning that we can actually multiply them. Now let's say we're going to we're going to find AB, and let's see we're going to find BA. Now let's see if these could actually work. Now as I said before, you have to pay attention to the order. Now paying attention to the order in a particular way, because they don't have to be the same order for you to for you to be able to multiply them. Now looking at matrix A and matrix B, if we're going to multiply them, so it's a 2 by 2 by a 2 by 1. Now, can we multiply these, or what is the criteria for two matrix to be able to, for two matrix to be conformable then, or to be able to can multiply? Now, so remember, this is in the form row by column, row by column. So hold on, C should be here, yeah, column. Now once number of columns in the first matrix is equal to the number of rows in the second matrix, that means they are conformable, meaning that we can multiply them. So I'm going to repeat that. Once the number of columns in the first matrix is equal to the number of rows in the second matrix, that means they are conformable, meaning that you can multiply them. So we can multiply these. So another thing that I should show you is that because the number of rows in the number of columns in the first matrix is equal to the number of rows in the second matrix, we can multiply them, and also the result is going to be the values at the end, each end. So the result for the multiplication of this matrix is going to be a 2 by 1. So 1 here and a 2 here. So the result is going to be a 2 by 1. Let's see if this is true. So we are finding AB. So A is 1, 2, 3, 4, and B is 1, 3. Now whenever you're multiplying matrix, you multiply it in this order. So it's the first row by the first column. Just put a C because I'm running out of space. So it's the first row by the first column. So it's the first row by the first column. So we're going to have 1 times 1. That's going to give us 1 plus 2 times 3, that's going to give us 6. Then we are finished because we don't have any more rows to multiply here. So I'm going to multiply second row by first column. So to multiply this, it's going to be second row by first column. So I'm just going to put a C for column. So it's 3 times 1. So it's 3 times 1, which is 3, plus 4 times 3, which is 12. So what I'm going to get, I'm going to add these. I'm going to have 7, and I'm going to have 15. So this is the result. And if you look at the result, what order is the result? 2 rows, 1, 2, and 1 column. So as you can see, to determine if two matrices are conformable, or to determine if they can multiply by each other, you have to make sure that the number of columns in the first matrix is equal to the number of rows in the second matrix, and the result is going to be the end numbers, the row for the first matrix, and the number of row for the first matrix and number of column for the second matrix. That's going to be the result. So let's look at a more let's look at multiplying two by two matrix. So remember, multiplying matrix, they don't have to be of the same order. But let's look at a 2 by 2 matrix. So let's say we have so just switch paper. I don't think this is going to have enough space. So let's switch papers. So let's say we had M, matrix M, 1, 3, 4, and 2. And we have matrix N. Hold on. Realize that I did not do something on this paper. I showed you how to find AB, but let's look at BA. Can we multiply BA? Now BA, we look at the order. So B is a 2 by 1 by a 2 by 2. Now can we multiply these two matrices? No. Why? Because the number of column in the first matrix is not equal to the number of rows in the second matrix. Let me show you what I'm referring to. So matrix B is going to go to the front, so it's 1 and 3, and matrix A is going to come at the end here, 1, 2, 3, 4. So remember, when we multiply matrices, first row times first column, first row times second column, second row times so I'm going to have to write that down, but let's write it down. So hold on, put it on this paper. So when you're multiplying matrix, it's goes like this: first row by first column, then we multiply first row by second column. Then after we are finished with the first row and the columns, we move on to second row, if there's anything like that. So it's second row by first column and second row by second column. So I'm going to work examples of with those. So that is how you would multiply a matrix. So it's first row by first column, first row by second column, second row by first column, second row by second column. So I'm going to work examples like that. So let's just go back to this. I hope that didn't confuse you. So let's go back to BA. So multiplying B times A, remember it's first row times first column. We're looking at B. B don't really have a row. It just have one value. So we wouldn't consider it to be a row. So 1 times 1 is 1, but which value would we multiply the 3 by? We don't have any value to multiply the 3 by, so that means this matrix is not conformable. That means we cannot multiply them. So hopefully you understand that. So let's go back to the to M and N. So remember, you can always re-watch the video. You can always re-watch the video. All right, so let's look at matrix N. So I'm going to put N here. N, matrix N is, let's call it 3, 2, 1, 4 for matrix N. Now, with matrix N, we are going to find Mn. So remember, we need to check the order. So M is a 2 by 2 by a 2 by 2. So once the number of columns in the first matrix is equal to the number of rows in the second column, that means they are conformable. So they are the same. Yes, so we can multiply them, and the result is going to be a 2 by 2 matrix. So let's multiply them. So we're going to have 1, 3, 4, 2, 3, 2, 1, 4. So I'm going to show the step by step working out for this one. So we're going to multiply. So remember, we multiply so we multiply first row. Let me use a different marker. So we're going to multiply, all right, use a pen. So we're going to multiply first row by first column. So we're going to multiply. So remember, this is A, this is B, this is C, this is D, this is A, this is B, this is C, this is D. So we're going to multiply first row by first column. So we're going to multiply A times A, B times C. That's the first row, first column. So let me write it out. So I'm going to have 1 times 3 plus 3 times 1. That's for the first row, first column. Then we move on to the first row, second column, just like what I have in the corner up here. So it's first row, first column. Then when we're finished with that, multiply first row, second column. So it's 1 times 2 plus 3 times 4. 3 times 4. So that was the first row, first column, first row, second column. Then we're going to move on to the second row, first column, second row, second column. So with the second row, first column, we're going to multiply 4 times 3 plus 2 times 1. 2 times 1. Then I'm finished with the second row, first column. I'm going to multiply second row, second column. So I'm going to have 4 times 2 plus 2 times 4. 2 times 4. So remember, you can always watch the video over and over. So let's multiply then add. So we're going to have 1 times 3, that's 3. 3 times 1, that's 3. Put by the plus sign. Then we have 3 4s or 4 3s, that's 12. Plus 2 1s, that's 2. And we have 1 times 2, that's 2. Plus 3 times 4, that's 12. 4 times 2, that's 8. Plus 2 times 4, that's 8. So we're going to add now. 3 plus 3, that's 6. 2 plus 12, that's 14. 12 plus 2, that's 14. 8 plus 8, that's 16. So this would be the answer for for Mn. That would be the answer for Mn. Now, let's see if we can spin the matrix around. So let's see if we can find Nm and see if Mn is equal to Mn. Let's see. So let's see. So we're looking for Nm. We just found Mn a while ago, so now we're looking for Nm. So Nm. So Nm. That's what we're looking for. So N is 3 2 1 4. M is 1, 3, 4, 2. So remember, multiply matrix, it's first row, first column. So we're going to do it step by step. So it's after probably this question, we can just skip steps because it's practically easy. Just that you have to go over it over and over and over and over. Persons learn best by repetition over and doing the questions over and over. Even if you have to do one question over and over and over and over and over, do it about 100 times, then you move on to another question. So we're going to multiply. So first row, first column. So it's 3 times 1. 3 times 1 plus 2 times 4. 2 times 4. So we'll finish with first row, first column. So we'll move on to first row, second column. So it's 3 times 3 plus 2 times 2. Then we are finished with the first row and the 2 columns. So now we're going to move on to the second row and the columns. So second row with first column is 1 times 1 plus 4 times 4. So we'll finish with second row, first column. We'll move on to second row, second column. So it's 1 times 3 plus 4 times 2. So finish with that now. So we'll just go ahead and multiply, then add. So I'm going to add 3 times 1, which is 3, plus 2 4s, that is 8. Plus, then here we have 1 times 1, that is 1, plus 4 times 4, that is 16. Here we have 3 3s, that's 9, plus 4 2 2s, that's 4. Then we have 1 times 3, that is 3. Then we have plus, we have 4 times 2, that is 8. So we'll move on here. So we have add now. So this 3 plus 8, that's 11. 1 plus 16, that's 17. 9 plus 4, that's 13. And 3 plus 8, that is also 11. So let's compare our answers. So this is mn was equal to 6, 14, 14 and 16. That was what mn was equal to, and nm is equal to 11, 13, 17 and 11. So as you can see, mn is not equal to nm, or what they say in the syllabus, it's none or not commutative. So mn and nm, they are not commutative. So hopefully students remember about commutative law. So I'm going to work another example on multiplication matrix. This time I'm going to look at how we would multiply a matrix when it's squared. So let's say we had a different color. Let's say we had a matrix B, and matrix B is, let's say, 3 1 4 2. Let us say that's matrix B. Now in the exam, open the booklet, they say you're supposed to evaluate B squared. Now B squared does not mean that you're going to open bracket 3 1 4 2 and then you bust a big square up there and say, yeah, this easy. 3 3 is 9, 1 1 a 1, 4 4 a 16, 2 2 is a 4. No, this is not correct. That is not correct. So B squared is actually equal to B multiplied by B, meaning you're not going to square the values in the matrix, but you're going to have to actually multiply the matrix by itself. So it's 3 1 4 1 multiplied by 3 1 4 2. 3 1 4 2 multiplied by 3 1 4 2. This is how you would actually find B squared. So you're going to multiply first row, first column, first row, second column, second row, first column, second row, second column. So let's see, use a different color marker. So we're going to multiply. So it's 3 times 3, 3 times 3 plus 1 times 4, 1 times 4. So that was the first row, first column. We're going to move on to the first row, second column. So it's going to be 3 times 1 plus 1 times 2. So we're finished with the rows, first row and the 2 columns. So now we're going to move on to the second row and the 2 columns. So it's 4 times 3, 4 times 3 plus 2 times 4, 2 times 4. Then that was the second row, first column. So we'll move on to second row, second column. So it's 4 times 1, 4 times 1 plus 2 times 2, 2 times 2, which is 3 3s 9. 1 times 4 is 4. 3 times 4, that is 12 plus 8. 3 1s 3 plus 1 times 2 is 2. Then we have 4 1s 4 plus 2 times 2 is 4. Then we'll go ahead and we'll add. So 9 plus 4, that's 13. 3 plus 2, that's 5. 12 plus 8, that is 20. And 4 plus 4, that is 8. So this would be the answer for b squared. So hopefully you understand what I was doing when I was multiplying matrix. So as I said, I'm going to have to break the video here, then do another one. I'm going to combine all the videos to make just one video. So that is multiplication on matrix. Next we'll be looking at in singular matrix, non-singular matrix, stuff like that in the next part of the video.